Okay, so today's video is going to be Unit 1.1, and this is Day 2. And we're going to be talking a little bit more about degree, but we're also going to be talking about factors of different terms. So we're going to have to rely on some of our vocab knowledge, so make sure that we have the understanding there. But basically our goal today is to determine the number of terms of an algebraic expression and its factors, and interpret what an expression represents in terms of its context. Okay, and just so we have a reminder of some of the things that we've been working with, let's take a look at the following expression. Now the key piece to understand is that this entire thing is an algebraic expression. It's not an equation because it doesn't have an equal sign, and that it also has some parts to it. And those parts are terms. And so if we look at each individual, we have 9x squared, we have negative 5y to the third, x to the second, and then positive 8. Those are the three different terms of this algebraic expression. And those are one of the things that we're going to have to get used to, is identifying pieces based on what the term is and knowing that the entire thing is an algebraic expression. And then just a note, we know that this has three terms because it's simplified. If we look at each individual one of those pieces before we call them terms, we know that there are no like terms between them. They're all kind of individual and they're unique. And so since there is nothing that we can do with this to simplify it, since there are three different pieces to it, we know that there are three different terms. So we just have to make sure that we know that we always need to simplify before we determine the number of terms. And that's something that we're going to be doing here. And so the first thing that we're going to do is we're going to determine the highest degree of each of the terms and the number of terms of an expression. And so if you look at it, the first thing that we do is we always simplify the expression using our order of operations. So when we look at something, we recognize what we need to do, and then we go ahead and simplify it as much as we can, and then we go to step 2 and step 3. So the first thing that we're going to do is, since we see this parentheses and anything out in front of the parentheses that's immediately there gets multiplied or distributed. Now if you notice, what I'm going to do is I'm going to take this entire negative 10 or this minus 10, and so I also need to distribute subtraction as well as the number being multiplied in front, but I can do those simultaneously. So I'm going to multiply both this and this by negative 10. So we have 210 p squared r minus 10p to the second and minus 10r to the second. Notice I kept that subtraction and still multiplied it by 10. Now I look for any like terms, and in this case we have p squared r, p squared, and r squared, which are not like terms. And so in this situation we don't have any like terms, so that we can immediately move on and say that this is simplified because there are no like terms. And so now the process is to identify how many terms there are of this expression. And in this case, since we basically identify each unique different term, there are 3, because we have this one here, and this one here. They're all unique. They don't share any common variables altogether, and so we have our different terms. Now the last thing that we need to do is we need to determine the highest degree. So in each term, so we determine each degree of each term, and so we simply add in our hidden exponents. So this is p squared r to the first, so that means that this term has a degree of, this is 2 plus 1, so that gives me a degree of 3. Negative 10p squared has a degree of 2 because the exponent value is 2 and that's the only variable that's there. And then this one also is a degree of 2. And so our highest degree term is 210p squared r. So once we are done simplifying, we then identify the number of terms, and then from each one of those we find the degree and find which one or which term has the highest degree. Now the last skill that we're going to look at is finding factors. And so the first thing that we have to understand is what is a factor. And those are basically numbers that multiply together to produce another number. And so the idea is that we're looking for pieces of multiplication, and that's really what we're going to come down to. Factors are that they are pieces of multiplication. Now, one of the other words that you've been familiar with before is something that we call prime factors. Now, prime factors are no different than other factors. The only difference is that the numbers that we're looking for to multiply to give us other numbers, those are all prime numbers. And so we've used factor trees to produce prime numbers for prime factoring, something that you've done previously. And so the idea is that we're looking for factors of this particular term here, 35y to the third, x to the second. And so the way that we go about this is we look at just the number first. So we look at 35, and we think about numbers that multiply together to give us 35, and some of those are 5 and 7. And when we look at that, 5 is a prime number, and 7 is a prime number. Now with variables, it works a little bit differently, but it's really not that complex here. And so the values that multiply together to give us y to the third are simply y times y times y. And so if we were to put this together as a string, we have 5 times 7 times y times y times y. And then we look at x, and since that's x to the second, that's simply x times x, and we can add that to our string of x times x. And so here, this is just an example of a prime factorization. Notice that all the variables are written out based on how many there are within that given exponent. So we have y times y times y, or y to the third, and we have x times x, or x to the second. And then also with the number we have 5 times 7. And so the idea of finding factors is basically writing out our variables and then writing out our numbers in their prime factors. And so basically what we did today, things that we need to take away from this, is simplifying before finding the number, finding the highest degree, and remember degree is the total exponents of variables in just a single term. So the one thing that we have to just make sure that we realize from that is only the variables in one specific term. We don't count going forward with every single term. And then finding factors, remember factors are pieces of multiplication. And so that's pretty much it for today. And make sure that you're looking for the post quiz too as well.